All right, so take a little bit of a review from last week. One of the things we're going to have to be able to do today is you're going to have to be able to find these zeros. We talked about why we wanted to be able to find those zeros last week. We'll talk about it here in just a second. So remember, when you're given a zero, that essentially tells us that x plus 3 is a factor. Okay, so if mine of my zeros is -3, that means we put -3 inside of the box. So then we've got 2, 9, 4, and -15. Because remember, when we get this remainder, if it is in fact a 0, that should be 0. And then we can have a second factor. So we drop down the 2. -3 times 2 is -6. 9 plus -6 is 3. That's -9. That's -5. That's 15. 0, which is perfect. So now we can write our factors. Our factors are x plus 3, which they gave us. And then our second factor is right there. So we started with cubed, so it's squared. And now we're going to use that to find our zeros. So the first 0, pretty straightforward. They already told us it's -3. The second 0 means we have to set 2x squared plus 3x minus 5 equal to 0. Quadratic trinomial, so we use the x method. A times c on the top, which is -10. My a value is 2, so we're going to divide this middle part by 2. My b value is 3, so that's -5, nope. 5 and -2. So when we're finding the zeros then, we talked about this the other day, kind of cheat mode a little bit. It's the opposites. So my zeros are -3, -5 halves, and 2. I'm sorry, 1. 1. Should be 1. -2 divided by 2 is -1, so it should just be 1. So there are my zeros. So now what we're going to do today and how we're going to use this today. Today we're going to use those zeros plus a couple of other things to work on the last section of this chapter, which is graphing polynomial functions. So we've added them, we've subtracted them, we've multiplied them, we've divided them. We found the zeros in a number of ways. Now we're going to go ahead and graph them. Last section of the chapter as well. We'll spend a couple days on this. We'll get through a vast majority of the notes today. Look at a couple examples tomorrow and we'll call it good. So when we're graphing polynomial functions, there are several things that we need to look at. And we've talked about end behavior in the past, so this isn't anything new. I think this was day 1. We talked about those different end behaviors, and this was actually on your quiz. Here's just a different way to look at them and maybe a little bit of an easier mode than the last time we put these in your notes. But remember that end behavior depends on your degree and the leading coefficient. So this first row here, or this first column, I'm sorry, that's the positive or negative. That's talking about your leading coefficient. Okay. These are talking about the degree of your polynomial. In the middle is kind of what the graph would look like. So if we have an odd degree that's positive, if you remember, odd degree and positive, the end behaviors were in the first and third quadrants. If it was odd, meaning it's 1, 3, 5, 7, so on and so forth. If it's odd and negative, the end behaviors were in the second and fourth quadrants. Again, on a side note, if you forget where the quadrants are, that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If it's even, meaning 2, 4, 6, 8, ... If it's even and the leading coefficient is positive, its end behaviors are in 1 and 2. And if it's even and negative, your end behaviors are 2 and 4. So we want to know the end behaviors because they kind of tell us where to start and be done. It's not technically the start, it's not technically the finish, but it's easier to talk about it like that. So where does it start? Where does it end? We'll always go left to right. So that's the first thing that we need to know and understand is what those end behaviors look like. The other thing that we need to know is what's called multiplicity. And this is a new term. The multiplicity, we're talking about the zeros and how many times that zero occurs. So the multiplicity of a zero is the number of times that it appears or the number of times that it happens. And that multiplicity is going to do something very specific for us. It's going to tell us if the graph goes through that zero or if it bounces off of it. It has to do one of those two things. It either has to bounce off it or it has to go through it. We'll talk about that in just a second, but first let's look at these examples and figure out what the zeros are as well as the multiplicity of them. So if I look at this first one, f of x is equal to x plus 2, x plus 5, and 2. First thing I'm going to find is its zeros. And we've done this zero things lots of times. So I shouldn't have to put x plus 2 equals 0, x plus 5 equals 0, and x plus 2 equals 0. You should just be able to tell me what makes that 0. Well, negative 2 makes that 0. What makes x plus 5 0? Negative 5 makes that 0. What makes x plus 2 0? Negative 2 makes that 0. So my zeros for this are negative 5 and negative 2. I've got two zeros. The multiplicity. Multiplicity talks about how many times these occur. Negative 5. If I look at negative 5, negative 5 only occurs once. So that means it has a multiplicity of 1. If we think about this as kind of being this table type of thing, negative 5 has a multiplicity of 1 because it only occurs once. Negative 2 happens twice. So negative 2 has a multiplicity of 2. And that's how many times those things occur. Okay. So we can find the zeros and we can find the multiplicity. So if we look at the next one, if we look at f of x is equal to x minus 1 squared times x plus 2 to the 5th and x minus 8. The zeros. What makes x minus 1 0? 1. What makes x plus 2 0? Negative 2. And what makes x minus 8 0? 8. So those are my zeros. The multiplicity. How many times does x minus 1 happen? It happens twice because of that exponent up there. Okay, so this would be just like having, this would be, remember, just like having x minus 1 times x minus 1. So 1 has a multiplicity of 2. What's the multiplicity of negative 2? It happens 5 times. It has an exponent of 5. So it happens 5 times. How many times is the multiplicity of 8? 1. Okay. So there's my zeros, and there's my multiplicity. So we can find end behavior. We can find multiplicity of these. Now, what does that multiplicity do? And how does that multiplicity help me graph it? So how does multiplicity affect a graph? If you have an odd multiplicity, okay, so for your notes, how does multiplicity affect your graph? If you have an odd multiplicity, 1, 3, 5, blah, 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 the graph is going to go through that point. So say I had a 0 right there, which is this point right here. When I say that it goes through it, it means it just goes right through it. There's going to be some bending to these, but it's not going to be a straight line necessarily, but it's going to go straight through it. That's if it's an odd multiplicity, 1, 3, 5, so on and so forth. If the multiplicity is even, I don't know why it says 2 there. If the multiplicity is even, 2, 4, 6, 8, who do we appreciate? Oh, come on, that was funny. Thank you. Enertson. Oh. If it has a multiplicity that's even, 2, 4, 6, 8, then it's going to bounce. Meaning it's going to come down to it, it's going to get to it, and it's going to bounce back up. Or it's going to bounce down. Either way, it's going to bounce. Now, does it do different things as the multiplicities get higher? Yes, it does. We're not going to worry about it flattening out before it gets to it. We're not going to worry about that kind of thing. We're just going to say if it's odd, it goes through it, and if it's even, it bounces off of it. So in order to graph, we need to be able to find 3 things. We need to be able to find the zeros, we need to be able to find the multiplicity, and we need to know what the end behaviors are. Then we can graph them. And as long as we can find those 3 things, it's not too bad to do. So then let's take a look at this example. Let's find the zeros, the end behavior, and graph. I'm going to add in there find the multiplicity as well. But so here's our problem. We've got f of x is equal to x times x minus 4 times x plus 3. So the first thing, I'm going to find the zeros. So my zeros, what makes this 0? What makes this one 0? Just 0. Just 0. What makes x minus 4 0? 4. And what makes x plus 3 0? Negative 3. So those are my zeros. Now I'm going to write down here multiplicity because we need that next. I'm just going to put mult. How many times does the 0, 0 occur? Once. How many times does the 0, 4 occur? Once. And how many times does the 0, negative 3 occur? Once. So they all occur once. So we know the zeros. We know the multiplicity. Now I got to talk about the end behavior. So for the end behavior, we need to know the degree. And we need to know if it's positive, the leading coefficient is positive or negative. Degree, when they're this way, kind of hard to tell what the degree is. You don't know what the leading coefficient is. You don't have it in standard form. The multiplicity, if you add up the multiplicity, it tells you the degree. When you add up the multiplicity, it tells you the degree. So the degree of this is it's a third degree polynomial. When you look at if this is positive or negative, you look at just the x's. Do you see any negatives in front of any of the x's? Nope. So it's positive. So this is odd because 3 is odd and positive. So we've got the zeros, we've got the multiplicity, we've got the end behaviors. So I always do the end behaviors first when I graph. It's odd and positive. So your little chart in there, odd and positive, is 1 and 3. So the end behavior is what I always do first, because that's going to help me know where to start and know where to end. Next thing I do is I plot my points. Remember, the zeros are where they cross the x-axis. So it crosses the x-axis at 0, 4, and negative 3. Now we're going to graph this from left to right. So my graph, we're starting down in quadrant 3. It's coming up to negative 3. Negative 3, I look at its multiplicity. Negative 3 has a multiplicity of 1, which is odd. So it's going to go through it. So it's going to go through negative 3. When it gets halfway between negative 3 and the next point, it's going to turn and come back down towards it. The next point I come to is 0. I look at 0's multiplicity. It has a multiplicity of 1, which is odd. So it goes through it. So it maybe comes down here somewhere, but it's got to turn back up. Now it gets to 4. 4 has a multiplicity of 1, so it goes through it. And that's an approximate guess of what the graph would look like. Why is it an approximate guess where it's going to be at? I have no idea. That might be way up there. That might be way down there. I don't know. And we don't care in this class. These are called relative maximums and relative minimums. That's a pre-calc problem. Okay? We're just sketching. Okay? But that's what that graph looks like. Okay? So you find the end behavior, you find the zeros, you find the multiplicity, then you graph. Let's look at another one. Kind of in the same mode. We got f of x is equal to x squared times x minus 2 cubed, x plus 3. Again, we'll do it together. X squared equals 0, so what does x equal? 0. So one of my zeros is 0. X minus 2 equals 0, so my next one is 2. And my last one is negative 3. Everybody knows how we got those, right? We just set each of these individual pieces equal to 0 and solved. Talk about multiplicity. So M-U-L-T. How many times does 0 occur? Twice. How many times does 2 occur? And how many times does negative 3 occur? Once. Okay, so there's all my multiplicities. So we've got zeros, we've got multiplicities, now we do end behavior. So I need the degree. 2 plus 3 plus 1 is 6. So it is even. If I look at all my x's, they're all positive, right? So it's even and positive. Even and positive is 1 and 2. So I put my end behaviors on my graph. Now I plot my points. My zeros are 0, 2, and -3. So I know it has to start in that upper left-hand quadrant. So it's starting up there. It's coming down. It gets down to -3. -3 has a multiplicity of 1. So does it bounce off it or go through it? Goes through. Gets about halfway, it turns and comes back up. It gets to 0. 0 has a multiplicity of 2, which is even. So does it go through it or bounce off of it? So it's going to go up to it and bounce off it and come back down. Now it's got to turn again because it's got to get back to 2. 2 has a multiplicity of 3, which is odd. So it goes through it. So that's what your graph looks like. And again, these are not right, but we don't care. How is it so far? Not bad? All right, now those first ones we've been giving it to you and been nice to you. Now we're not going to be nice anymore. So now we're going to do the same thing, but now it's not factored for you. The first 3 examples we've done have all been factored for you. Now it's not factored. Well, that's why we've been doing what we've been doing for the past few days, is we're working on factoring. Okay, we'll do it together. So we've got a trinomial, so we know we're eventually going to try the x method. However, what do we have to do first? Take out GCF. GCF is 2. X squared. So that gives me x squared plus x minus 6. Perfect. Trinomial means try the x method. So -6 and 1. 3 and 2. 3 and -2. So I'm just going to write it in factored form. So it's x squared, x plus 3, and x minus 2. That's factored form. Okay, now it equals 0. So again, we start asking ourselves the questions. X squared, so that's 0. X plus 3.
-3.
And x minus 2. Positive 2. Multiplicity. 0 has a multiplicity of 2. -3 has a multiplicity of 1. And 2 has a multiplicity of 1. We've got the multiplicities taken care of. End behavior. 1, 2, 3, 4. So it's a 4th degree polynomial. So that's, in my book, that's even. And if we look at the leading coefficient, so I can just look up here now, that leading coefficient is positive. So it's even and positive. What quadrants are even and positive? 1 and 2. 1 and 2. My zeros are at 0, -3, and 2. Now you have to be careful at this point. You got to make sure you're coming down. Make sure you look at -3 because we got to go through -3 first. -3 has a multiplicity of 1. So it's going to go through it. It's going to bounce back up. Now 0 has a multiplicity of 2. So it's going to bounce off of it And then 2 has a multiplicity of 1, something like that. Again, it's just a sketch. Any questions with that example? All right, next one, and last one, I think. Yep, last one. So f of x is equal to x cubed plus 2x squared. Make that minus 4x minus 8. My secretary messed up when they typed. I'm my own secretary, so. So 4 terms. We talked about this on Friday. If you have 4 terms and I don't give you a 0, what method do you use? Box method. Okay. So we're going to use the box method for this. Again, we talked about it on Friday, but remember, in here and during this class, if you're given 4 terms and not one of the zeros, the box method will work. In the real world, where so many of you will be doing all of this stuff, yeah, that's not the case. Another joke that got nothing. Thank you. So x cubed, 2x squared, negative 4x, and negative 8. GCF is x. GCF of 2x squared and negative 8. It's just 2, right? So there's my first factor, x plus 2. GCF now going this direction, x squared. GCF going that way. The first term is negative, so it has to be negative and negative 4. So my second factor is x squared minus 4. Because we're practicing, if I look at this right here, I should always double check to make sure everything is factored completely. That's a difference of squares. So you could factor this further to x plus 2 times x minus 2 times x plus 2. Remember, difference of squares. It's a square root of a minus the square root of b, the square root of a plus the square root of b. You could do that. On a side note, okay, because you're just finding the zeros, you could have just put x minus 4 equals 0. Add 4 to both sides. And then remember, we take the square root. But what does everybody forget? To put plus or minus. So that's why it's not a bad idea to factor it. What are my zeros? Negative 2 and 2. Multiplicity. How many times does negative 2 happen? Negative 2 happens twice. Remember, when I say the multiplicity is negative 2, that's x plus 2 and x plus 2. So that happens twice. Common error in there would be to say it only happens once because I only see x minus 2 once. But remember, these are our zeros. 2 happens once. End behavior. Well, we can just look at our leading coefficient. Our leading coefficient is x to the third. Our leading term is x to the third. So it's the third degree, which is odd. And my leading coefficient is just 1, so it's positive. So odd and positive is 1 and 3. Yep. My zeros are at negative 2 and 2. So my graph out of quadrant 3 gets up to negative 2. Does it go through negative 2 or bounce off of it? Bounce off it because it has a multiplicity that's even. It gets about halfway, curls back up. When it gets to 2, it goes through it. And the nice thing about these, and why it's always a good idea to do the end behaviors first, why I put them there, because it shows me that I got it right. I probably got it right. Because notice how when I graphed it, that's what happened. I knew it had to start down there, then I graphed it and it did finish where it was supposed to finish. So when you're graphing polynomials, find the zeros. Find the multiplicity of those zeros to help you find the end behavior, and then graph it. Okay? You're going to get practice now for a couple days. You got a practice assignment sitting in Schoology. We're also going to use tomorrow as practice for graphing polynomials as well. We're looking at a review day on Thursday, test on Friday. And the test will be over all of Unit 3, meaning the stuff you were quizzed on is also going to be on this assessment. Okay? I'll post the review tomorrow morning.